Hi students, I am your Nagini ma'am chemistry mentor. In today's session, I am going to explain about easy way to understand molecular orbital structure of benzene. This is a topic from hydrocarbons lesson 11th class chemistry. Okay, so now first of all benzene benzene formula C6H6 C6H6. So carbon atomic number 6, electronic configuration 1s2 2s2 2p2 1s2 2s2 2p2. So here orbital electronic configuration, if you see orbital structures 2s 2p. In 2s 2 electrons, in 2p 2 electrons are there, 2s 1 2 electrons, 2p 2 electrons are there. Okay, so this is the ground state electronic configuration. This is ground state electronic configuration. Okay, now I'm writing excited state. First excited state electronic configuration. First excited state electronic configuration 2s 2p 2s 2p. In 2s, 2 electrons, 1 electron is jumping to 2p orbital, vacant orbital. Here vacant orbital is there, that's a promotion of electron takes place here. From 2s orbital, 1 electron is excited to the vacant p orbital. So here in 2s, 1 electron, in 2p, 3 electrons. Clear? So this is px, py, pz. This is completely 2p subshell. Clear? 2s, 2p. Right. Here, if you see the benzene structure, students, C6H6, C6H6, CH, double bond, CH, single bond CH, double bond CH, single bond CH, double bond CH. This is the structure. So here around each carbon total, how many sigma bonds are there? Here 1, 2, with hydrogen 1 sigma. Total 3 sigma bonds are there. Around each carbon 3 sigma bonds and 1 pi bond is there. Are you following? Around this carbon, in double bond we know that 1 sigma 1 pi. Here already single bonds always represent always sigma bond only. Are you following? This is sigma, this is sigma. In double bond 1 sigma, here 1 sigma, with hydrogen 1 sigma. Total 3 sigma bonds are there around each carbon. Okay, and one more is pi bond. Clear? 3 sigma bonds. Hybrid orbitals always forms the sigma bonds, we know that. Okay, the pure atomic orbitals undergoing hybridization produces hybridized orbitals. Okay, so in benzene, all the 6 carbon atoms undergoes, here all 6 carbon atoms undergoes sp2 hybridization. Which hybridization? sp2. Because around each carbon, how many sigma bonds are there? 1 2 3. Total 3 sigma bonds. 3 sigma bonds means here it is carbon undergoes sp2 hybridization. Are you following? In benzene, all the 6 carbons. In benzene, all 6 carbon atoms. In benzene, all 6 carbon atoms, 6 carbon atoms undergoes sp2 hybridization. sp2 hybridization. Clear? Undergoes sp2 hybridization. Okay, to form three hybrid orbitals. To form hybrid orbitals. Okay, now listen here. To form hybrid orbitals. So here around each carbon 3 sigma bonds are there, na? So 3 sigma bonds. So that's why here 3 hybrid orbitals should form. So here that's why here I'm taking 3 pure atomic orbitals, 1 s orbital, 2 p orbitals. So 1 s, 2 p orbitals. Clear? So here from here to 2 p orbitals. 3 orbitals undergoing hybridization produces 3 sp2 hybridized orbitals. 1 s orbital, see here, 1 s orbital, 1 s orbital, 2 p orbitals. Okay, 2 p orbitals undergoes hybridization. Okay, produces 3 sp2 hybridized orbitals. 1 plus 2, 3, 1 plus 2, 3. Total 3 hybrid orbitals. Okay. S1, P how many? 2. sp2 hybrid orbitals. Hybrid orbitals. Now if you see the structure, orbitals, one s orbital, this is s orbital, one s orbital, okay, nucleus. Next, two p orbitals. Which orbitals? Px, py. Okay, so px orbital, two p orbitals. This is px orbital. Next, py orbital. This is py orbital. Clear? Px, py orbitals undergoing hybridization. Okay, one s orbital, two p orbitals. Undergoing hybridization means intermixing produces here both three orbitals belongs to carbon atom now, so here you have to take electrons like this, right? Okay, three electrons like this you take, right? Now produces total how many orbitals? 1 2 3 now, so total you will get the 3 sp2 hybridized orbitals. So here 3 sp2, see here how I am taking. This is one sp2 hybridized orbital. This is second sp2 hybridized orbital. This is third sp2 hybridized orbital. Clear? So total 3 sp2 hybrid orbitals are formed. These hybrid orbitals are present in a plane with the angle of separation of 120 degrees. Here angle is 120. Here angle is 120. Are you following? So with the separation of angle, how much? 120 degrees. Clear? 120 degrees. Here all sp2 hybridized orbitals are lying in the same plane. Okay, now are present in a plane with the angle of separation of 120 degrees. Clear? So here total 3 electrons. So 3 electrons, 1, 2, 3 electrons. Understood? Okay, now these 3 are sp2 hybridized orbitals. sp2 hybridized orbitals. Okay, so here like this is total 6 carbon atoms are there, so that's why we'll get the 6 sp2. Here each carbon is showing 3 each carbon is forming 3 sp2 hybridized orbital. So like that 6 carbon atoms you have to take. See here structure 6 sp2 hybridized orbitals, 6 hybridized orbital structure. See here total first 1 2 3 4 5 6. Here one each carbon atom is forming 3 sp2 hybridized orbital. So here like that 6 carbon atoms you have to take. See here structure. This is first carbon, this carbon. Okay, understanding? See here this carbon, sp2 hybridized orbital, this carbon. Next to this carbon. Okay, this carbon. See here. This is second carbon. Next this carbon, this carbon, sp2 hybridized orbital, sp2 hybridized orbital. So 3 carbons completed. Now fourth carbon, fourth carbon, fifth carbon, like this. So total 1 2 3 4 5 carbons completed. Sixth carbon, this is sixth carbon. Clear? So here total 6 carbons, 3 sp2 hybridized orbitals. Okay, so this is sp2 hybridized orbital, this is sp2, this is sp2, 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 sp2 hybridized orbitals. Are you following? All are sp2 sp2. Clear? sp2 hybridized orbitals. Okay. See here, each carbon atom two sp2 hybridized orbitals. This is one hybridized, this is another sp2 hybridized. These two sp2 hybridized orbitals undergoing end-to-end overlapping with the sp2 hybridized orbitals of two sp2 hybridized orbitals of adjacent carbon atoms. So here one sigma is sigma bond is formed, end-to-end overlapping. Are you following? This is which type of sigma bond is? This is which type of sigma bond? Sigma sp2 sp2. So that means sp2 orbital, sp2 hybrid orbital, both are undergoing end-to-end overlapping. So this is which type of sigma? Sigma sp2 type. Are you following? So here each sigma bond is sigma sp2 sp2. This is sigma sp2 sp2. This is sigma sp2 sp2 type. This is also sigma sp2 sp2. sp2 hybrid orbital, sp2 hybrid orbital. Are you following? Sigma sp2 sp2. Clear, students? Here total 3 sp2 hybridized orbitals are formed, Nana. In this 2 sp2 hybridized orbitals of each carbon atom undergoing end-to-end overlapping, Nana, with the 2 sp2 hybridized orbitals of 2 adjacent carbon atoms. See here, these 2 carbon atoms, these are hybrid orbitals, these 2 hybrid orbitals undergoing end-to-end overlapping, sigma bond is formed. Okay, here all are sigma bond is formed, single bond, single bond, single bond, single bond here. That means each carbon is forming the 2 sigma bonds. Here one sigma, here one sigma. Total 2 sigma bonds with the other 2 adjacent carbon atoms. Clear? So another sp2 hybridized orbital is there now. This one. See here, this is another sp2 hybridized orbital of each carbon atom. What happened? This is sp2 hybridized orbital of third sp2 hybridized orbital of each carbon atom undergoes end-to-end overlapping with the 6 hydrogen atoms. 6 hydrogen atoms s orbitals. Here hydrogen atom is there now. Here C6H6 now for compound. Hydrogen atomic number 1. Hydrogen atomic number 1. Atomic number 1s1, electronic configuration 1s1. In 1s 1 electron is there. S orbital shape is spherical shape. So here sp2, another sp2 hybridized orbital of each carbon undergoes end-to-end overlapping with the s orbital of the 6 hydrogen atoms, students. Understanding? So here one hydrogen atom. Are you following? Here one hydrogen atom. It is a spherical shape, hydrogen atom s orbital. This is a hydrogen atom s orbital spherical shape. This is s orbital spherical shape, and here also s orbital spherical shape, this one and this one. Clear? S orbital spherical shape. So here sigma bond is formed, end-to-end overlapping, sigma bond is formed. Clear? Sigma bond, 2 electrons, here 2 electrons, sigma bond, here 2 electrons, here also 2 electrons, 2 electrons, 2 electrons. Clear? So sigma bond is formed. So that means here sp2 hybridized orbitals of carbon atom undergoes end-to-end overlapping with the s orbital of hydrogen atom. So like that 6 carbon atoms sp2 hybrid orbitals undergoes end-to-end overlapping with the 6 hydrogen atoms s orbitals. Okay, so here we will get the 3 sigma bonds completed. Okay, coming to the structure, electronic configuration, here 2s px py, total 3 orbitals, 1s 2 p orbitals undergoing hybridization. Are you following? Hybridization produces 3 sp2 hybridized orbitals. What about this one? It is not undergoing hybridization. It is calling as unhybridized p orbital. So this unhybridized p orbital, students, dumbbell shape. Okay, the p orbital shape is dumbbell shape. This unhybridized p orbital of each carbon atom, it is lying perpendicular to the plane of the hybrid orbitals. Okay, now perpendicular. So that means here two lobes will be there in the dumbbell shape p orbital. Here one is back side, another one is front side. That means it is perpendicular. Okay, now pz orbital. See here perpendicular. So it is present in the same plane. Are you following? Three sp2 hybrid orbitals are present on the same plane. Are you following? Now I am taking the pz orbital. Clear? Pz orbital. So pz orbital is unhybridized orbital. So unhybridized orbital. So the unhybridized pz orbital lying perpendicular to the plane of the hybrid orbitals. Are you following, students? Perpendicular to the plane of the orbital. So that pz orbitals, unhybridized orbitals, if you take unhybridized orbitals like this. Understanding? These orbitals are pz orbitals. These are unhybridized orbitals. Understanding? Unhybridized orbital. Clear? Unhybridized orbital. It is not involved in the hybridization. Okay, these orbitals are forming pi bond nana. So that means unhybridized orbitals of the carbon atoms undergo sidewise overlapping. Understanding? Sidewise overlapping produces pi bond. Okay, pi bond is formed. So this is the here this lobe how it is there, it is perpendicular to the plane of the hybridized orbital. So above this one, here above this one, what will be there? Here which structure will be there above this one? That is hybrid orbital structure. That means those are present on the same plane, but these orbitals, unhybridized orbitals, present above and below the plane of the hybridized orbitals, means perpendicular to the plane of the plane of the hybridized orbitals. Okay, so here this is carbon atom, this carbon atom forming the here strong bond. Are you following? Here sigma bond, this is sigma bond. Okay, so in between the two each carbon atoms, two sigma bonds are formed. Correct? Here this carbon atom forming the two sigma bonds with other two adjacent carbon atoms. Correct? In a hybrid orbital structure we discussed. Okay, this is the hybrid orbital structure, sigma bonds. Now coming to these two orbitals, pz orbitals, unhybridized orbitals, these are undergoing sidewise overlapping. Are you following? So the 6p orbitals of 6 carbon atoms undergo sidewise overlapping in two different ways, students. Okay, na? Two different ways. Clear, students? The 6p orbitals of 6 carbon atoms. 6 carbon atoms are there now. 6p orbitals are there. Unhybridized orbitals. So these unhybridized orbitals undergo sidewise overlapping. Sidewise overlapping in two different ways. Okay. Sideways overlapping. This is which type of overlapping? Sideways. See here. This is sideways. So one type is like this one, and this one like this, and next this one. This is sideways overlapping. Are you following? So this lobe undergo sideways overlapping like this. Sideways overlapping. This is sideways overlapping. Okay, sideways overlapping takes place. And another one here, in two different ways we can understand. Here in two different ways 6 carbon atoms undergo sideways overlapping. This is one way, and another way is another structure. See here another structure, students. Another structure in second way. These are unhybridized orbitals. Above this one, perpendicular, what will be there? 3 sp2 hybridized orbitals of each carbon atom. 6 carbon atoms will be there. So they forms the stable bond, strong bond, sigma bond. Sigma bond. This is sigma. Okay. Sigma bond. Next, these orbitals are undergoing sidewise overlapping, students. Sidewise overlapping. See here, sidewise overlapping like this. This is the second way. This is the first method. This is the second way. Next, this lobe undergo sidewise overlapping. This lobe and this one. Are you following? So like this, two different ways. Okay, so two different ways unhybridized orbitals are undergoing sidewise overlapping. Clear? Sidewise overlapping. This causes resonance to take place. And here, what are the pi electrons are there? Pi electrons are pi electrons completely delocalized. Understanding? So here, from these two structures, we can write the one resultant structure, students. So here in this structure, pi electronic cloud above and below the plane of the ring. Here actually sigma bond. Here sigma bond is influenced by two carbon atoms. So that means sigma electrons are attracted by both the nuclei equally, students here. So, and that's why they cannot move freely, sigma bond. But pi electrons here, see here moving, well again here like this. Understanding? So in two different ways structures are there. So here pi electrons can move freely about the 6 carbon nuclei. Are you following? So 6 carbon nuclei, and this pi electronic cloud above and below the plane of the ring. Are you following? So this electronic cloud above and below the plane of the ring, above and below the plane of the ring. See here the final structure. Here we can take 6 carbon atoms, unhybridized orbitals, like this take. This is sigma bond, okay, sigma bond. And these unhybridized orbitals means pi electrons. Here forms pi bond sidewise overlapping. This pi electronic cloud above and below the plane of the ring. It is formed above and below the plane of the ring. Clear? So here this upper lobes. Here this is the lobes. Okay, this lobes like this. Okay, next below lobes there now, this one, this below lobes like this. Clear, students? So this red color is this is sigma bonds. Understanding? So that means these hybrid orbitals, these bonds are formed by the hybridized orbitals. These pi bonds there now, this is a electronic cloud. These lobes are undergoing sidewise overlapping. These up lobes, these are down lobes. Okay, this is the electronic cloud. It is formed above and below the plane of the, this is above. Okay, this is the below the plane of the hybridized orbital sigma bond. This is the plane of the hybridized orbitals. Understanding? So above and below the plane of the hybridized orbitals, electronic cloud is formed. Understand? This is the final structure of the unhybridized orbital structure. Understanding? So I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you, students.